All right, I'm kind of losing my patience here. The AP test is coming in and you still don't know how to integrate? Oh man, what am I doing out here? All right, doesn't matter. We have one thing I need you to understand. All we are doing here is that we need to go forwards and backwards. Okay? Look, it's not that hard. Okay? But we need something to look like this. And so, with all that is written out here, we just need to know how to go forwards and backwards with these types of trigonometric functions. So, the sine will go forwards into a cosine after a derivative, but the sine will go back to a negative cosine after taking the integral. I better not see anyone messing up the signs because everything is clearly written out here. Okay? And so same idea going forward is that cosine will go to negative sine after the derivative, but the cosine will go to positive sine during the integral. Always remember that if you are ever in doubt, you can go ahead and take the derivative of your answer to see if it matches up with the inside of the integral. 100 out of 100 times, you will always be checking your work like this.
But what about the tangent function?
I'm glad that you asked. So we clearly are missing the tangent function in here. But many of us would already know from before that the derivative of tangent of x in respect to x is going to be secant squared of x. Pretty nice. But what about the integral of tangent of x dx? What about that, huh? Well, if you were to guess that it should go backwards into secant, you are sadly mistaken. This is something that you will need to memorize in terms of what we need to do in the future, but we get something like this. Or if you would like it in terms of just sine and cosine, you can also do that by writing it like this as well. That's not a pretty bad deal. But then, of course, the answer is why? How in the world do we get to this from something so simple as tangent? Well, in any case, though, we can easily look back here and think about what the idea is for us to take one of these supposed answers and take its derivative. So why don't we do that here on the other corner? We are taking the negative natural log of cosine of x plus c as a result of integrating tangent. How did this come about? Well, we can always remember that we want our form of our integration to be tangent of x, which of course is going to be simply defined as the ratio of sine of x over cosine of x. Hopefully we can start seeing this in our minds now, that by throwing the natural log of cosine inside of the answer, that is how we reach that cosine of x in the denominator. So why don't we look about it this way? We take the derivative of this answer. So let's start here. So the negative natural log of the absolute value of cosine of x plus c, take its derivative. And so let's have a look at what each step provides. The negative natural log will then make it so that it's a negative 1 over cosine of x in the denominator. Now, if we ended it here, this clearly shows you don't have to do integration. But we still have one more step to go over because we have chain rule. We took the derivative of the outside function, which was natural log, and now we must take the derivative of the inside function, which is cosine of x. How convenient! That is written right there in our forward step. The derivative of cosine is going to be negative sine of x. And of course, the plus c will go to 0 from our differentiation. And how lovely. We get the negatives to cancel out, because those are being multiplied, and we end up with the exact ratio of the sine of x over cosine of x. And
isn't it wonderful?
it is
Not really.
that we get to return back to the tangent of x as a result of taking the derivative of that answer. Again, these steps are going to be very important for all of you getting ready for that exam. You have a way to check every single one of your answers, and you should be doing that. So let's get to a few practice problems, and hopefully I can stop being bothered about trig functions in the integral.